So the doubts related to topic rate, redox and reversible reactions. First one is question number 3. In question 3, which graph correctly shows a Maxwell-Boltzmann distribution of the energy? So whenever this graph is starting, it should start from the beginning, like because when no particles are there, they will have no energy. So it cannot be B. Then the second thing, the graph should not touch the x-axis. Why it should not touch the x-axis? Because what will happen if it touch the x-axis mean like we limit the maximum energy, but we cannot limit the maximum energy. The particles can have any energy, so there is no maximum value of the energy which the particle can have. So that's why C cannot be an answer. So it should not touch the x-axis. So we are left with A and we are left with D. But what is happening from A to D? So basically what happened, most of the particle will have average energy, like the energy which is more or less same for all particles, and few particles will have energy more than the activation or the higher energy. So when we check option A and option D, in option D, what is happening? The number of the particle which are having average energy, this is the number of the particle. Then the number of the particle which have high energy, that is constant. Horizontal line means that is constant. But that should not be constant. Basically what happened, the number of the particle which are having high energy, so that will decrease because most of the particle will have average energy and few particles will have high energy. So the number of the particle, as we move towards the higher side, the number of the particle decreases. But what is happening for D? The number of the particle remain constant. That's why it cannot be D. So the valid answer is A. So for question 3, the correct answer is A. Is it clear? So why B is wrong? Because the graph is not starting from the beginning. Why C is wrong? The graph is touching the axis. Why D is wrong? It means a particle which have the higher energy, that is constant. Next is question number 5. The chlorate ion ClO is formed when chlorine is dissolved in water. The equation is given: chlorine dissolved in water produce H plus, Cl minus and ClO minus. The concentration of a chloride ion could be increased. So basically this arrow, this is means a reversible reaction. So we have a chlorine molecule reacting with water or dissolved in water. As a result, it produces two protons, it produces chloride ions and it produces chlorate ion. So how the concentration of chlorate ion can be increased means how we can shift the equilibrium towards the right hand side. So if we want to shift the equilibrium towards the right hand side, either we should increase the amount of the reactant or we should reduce the amount of product so that the equilibrium shift towards the right hand side. So what can be done if we add sodium hydroxide? What is sodium hydroxide? Sodium hydroxide is a base. So this sodium hydroxide will react with acid, so amount of hydrogen ion in the equilibrium mixture will decrease. As the amount of the product decreases, where the equilibrium will shift? Equilibrium will shift towards the right hand side, because the hydrogen ion means the acid, and acid can react with an alkali. So A will be the right answer. Why not B, C or D? If we add hydrochloric acid, so when we add hydrochloric acid, it means H plus and Cl minus. So it means amount of the chloride ion increases. If amount of chloride ion increase, the equilibrium will shift towards the left hand side. Adding solid sodium chloride, same thing. If we add sodium chloride, it will dissociate into Na plus and Cl minus. Again, the amount of chloride ion increase, which cause the equilibrium to shift towards the right hand side. And adding potassium sulfate. So adding a potassium sulfate, it does not have any reaction here with, because you don't find a reagent which is reacting. Like when we add potassium sulfate, it will form potassium ion and sulfate ion. But they don't have, you cannot find their reactions with any of the reagents, so it does not cause any shifting of the equilibrium. That's why for question 5, A is the right answer. Is it clear? Question 5. Then in question 6, when solution of iodine and are titrated with sodium thiosulfate, the thiosulfate ions are oxidized too. So the equation for iodine thiosulfate titration is there. When we have iodine molecule reacted with thiosulfate ion, S2O3 with a charge -2. So as a result, what it produced 2 iodide ion, and it will produce S4O6 with a charge -2 or 2 minus. And the equation must be balanced. So this is the balance equation. So the thiosulfate ion is oxidized to what? It produces S4O6. So that's why D will be the right answer. Then question 8, E2. When chlorine gas is bubbled into aqueous potassium iodide solution, a redox reaction occurs. Give ionic equation for this reaction. So potassium iodide means iodide ion is there, and it is reacting with chlorine. So chlorine is more reactive. Always the more reactive halogen displaces a less reactive halogen from its compound. So when chlorine reacted with iodide ion, 2 iodide ion, it will form chloride ions, and as a result it will produce iodine molecule. In further experiment, 0.5 moles of chlorine was bubbled into aqueous solution containing 0.66 moles of potassium sodium iodide and 0.66 moles of sodium bromide. Assume that all of the chlorine gas has reacted. Calculate the number of moles of iodine and bromine produced and justify your answer in terms of reduction power of a bromide ion and iodide ion. So how to work out the number of the moles of iodine produced? So we have this, already we mentioned the equation that when we have Cl2, so this is the equation for reaction between chlorine and aqueous solution. So 0.66 moles of sodium iodide means the ratio between, when sodium iodide will dissociate, it will dissociate into one sodium ion and one iodide. So basically, if we have 0.66 moles of sodium iodide, same number of moles of iodide ion will be there. So what is the ratio between chlorine and iodide ion? The ratio between them is 1:2. So first, whenever we are finding a product, because we want how much iodine is there, so we always use a limiting reagent. So what will be the limiting reagent? Iodide ion will be a limiting reagent, because if you have 0.5 moles of chlorine gas, you need about 1 mole of iodine. But the ratio is 1:2. If you have 0.5, you need 1, but you don't have 1, you have only 0.66. So whenever you're finding a product, you always find from the limiting reagent. So we have chlorine, we have iodine. So, or we can also do, we can take the ratio between chlorine to iodine to find how many moles of chlorine will react, and from that moles, we can work out how many moles of iodine are produced, iodine molecule. So first we'll use the ratio. So for the ratio between chlorine and iodine, the ratio between them is 1 is to 2. So because iodine will be a limiting reagent, as 1 is to 2 is the ratio, and it is obvious if we have 0.5 moles of chlorine, we cannot get, we should have 1 mole of iodine, but we have only 0.66. So 0.66 is the limiting. So cross multiply. So when we cross multiply 0.66 divided by 2, so 0.33 moles will be there of chlorine which reacted. And from this 0.33 moles of chlorine which are reacted, how many moles of iodine is there? The ratio between chlorine molecule is to iodine molecule is 1 is to 1. So if we have 0.33 moles of chlorine, how many moles of iodine will be there? X. So we'll get 0.33 moles of iodine. So same number of moles we'll get for iodine. But what about the moles of a bromine produced? So again, when we write the equation for chlorine reacting with bromidine, it will form two chlorides and it will produce bromine molecule. So again, the ratio is 1 is to 2. But now what is the mole ratio we should use? Again, the mole ratio is 1 is to 2, but the thing is, how many moles, total number of the moles were 0.5. And in the beginning, out of 0.5, 0.33 moles have reacted. So how many moles are left to react with bromine? So originally it was 0.5, and out of 0.5, 0.33 has reacted. So 0.17 moles of chlorine are unreacted. So it means 0.17 will react with the remaining bromine. So cross multiply. When we cross multiply, it will be 0.17 divided by 2. And the thing is, because in the question we don't need how many bromide ions are there. The main thing what we need how many bromine molecules are produced. So when we take the ratio, now what is the limiting reagent here? The second part, when a chlorine is reacting with bromide ion, now chlorine is a limiting reagent. Why? Because we are left with only 0.17 moles of chlorine and we have 0.66 moles of bromide ion. So it means this is a limiting reagent. So from chlorine, when we work out the moles of bromine, this will give us the number of the bromide ion which will react. But that's not the main question. The main question is to get the number of the moles of bromine molecule. So this answer was 0.17 divided by 2, which is 0.085. That is the moles of bromide which react. But we need for bromine, so relation between bromine and chlorine molecule, where 1 mole of a chlorine produce 1 mole of a bromide ion. So ratio is 1 is to 1. If we are left with 0.17 moles, how many moles of bromine will be there? X. So that will be equal to 0.17. And when we compare the reduction power, iodine is good reducing agent as compared to bromidine. So reduction power, as we go down the group, it increases. Is it clear, this question? Then next question is 18. The doubt 18, 19 and 20. This question is about some reactions which can be used to manufacture hydrogen. So we can manufacture hydrogen with different techniques. For each first three reactions, state the initial and the final oxidation state of any element that has changed its oxidation number, hence decide which is redox reaction. So for a redox reaction, both oxidation and reduction should happen. Not only oxidation, it should be both oxidation and reduction. So you have to work out the oxidation number of each. When we write the oxidation number, hydrogen and carbon, first we have CH4. So in CH4, because hydrogen is, as we move across, like whenever two non-metals are there, when we move across the period, what happens? Electronegativity increases. So non-metal, which is like if two non-metals are there, so non-metal which is on the right hand side should have a negative oxidation state, and the non-metal which is on the left hand side should have a positive oxidation state. So when we talk about carbon and hydrogen, carbon belongs to group 4, so carbon belongs to group 4, it can be plus 4 or minus 4. And hydrogen is there, it can be plus 1 or minus 1. But how we know whether we have to take positive or negative? So on the left hand side, they are less electronegative. On the right hand side, they are more electronegative. So the one which is on the right hand side, you should use as a negative. So carbon I'll take as negative. And individual hydrogen, there are 4 hydrogen, but we, whenever we write the oxidation number, we write for individual or each. Same thing in water, each hydrogen is plus 1, oxygen is minus 2. In carbon monoxide, because the overall compound is neutral and there is carbon in oxygen, so if oxygen is minus 2, and whenever you are writing the oxidation number, you should start with the most electronegative first, which is, in this case, oxygen is more electronegative, so minus 1. Because the overall compound is neutral, so it should be uh, oxygen is minus 2, not minus 1. So if oxygen is minus 2, because the overall compound is neutral, so carbon should be plus 2. And when we say the oxidation number of a carbon is can be plus 4 or minus 4, it means it can be any number between this. Generally, like it can maximum, it can be plus 4, minimum minus 4, but it can have any number from plus 4 to minus 4. That's the main concept of oxidation number. Same thing like if there was chlorine, for chlorine we can say it is minus 1 or plus 7. So what does it mean? It means it can have any other oxidation number within this range. So hydrogen is an element, so 0. So hydrogen is plus 1 becomes 0. If plus 1 becomes 0, what we call? We call that as a reduction. And carbon is minus 4 become plus 2. So what we call? We call that as oxidation. So the first one is a redox reaction. And the same way you can work out for other reactions as well. Like example, oxygen is will be each oxygen is, when I write the total, each oxygen is minus 2, 3 oxygen will be minus 6, 1 potassium is plus 1, so 2 potassium will be plus 2, so carbon will be plus 4. So individual oxidation number I write at the top and the total at the bottom. In carbon dioxide, each oxygen is minus 2, so 2 oxygen will be minus 4, so the carbon individual should be plus 4. And water plus 1 minus 2, and potassium hydrogen carbonate, so minus 2. When I write the total plus 1 plus 1 plus 4 and minus 6. So for fourth reaction there is no change in oxidation number, so this is not a redox reaction. So basically the first reaction, as the carbon changes from minus 4 to plus 2 and hydrogen changes from plus 1 to 0, so that is oxidation and reduction. So the first reaction is a redox reaction. Is it clear? The first part, that how we work out the oxidation and reduction. So like this you can work out for all the three. Then discuss with reason the condition of temperature and pressure that would favor the production of hydrogen in reaction 1. So, and it's of 7 marks. See the weightage and condition on both yield and the rate. So you have to refer shifting of equilibrium as well as the speed of the reaction. The forward reaction, the first reaction, the forward reaction is endothermic. So if the forward reaction is endothermic, what it prefer? It prefer a high temperature. And when we increase the temperature, what will happen? The yield or the equilibrium will shift towards the right hand side. As equilibrium shift toward the right hand side, the yield will increase, as well as the rate is directly proportional to speed, temperature, so rate will also increase. Then when we check the pressure, we have 1 or 2 moles of the gas on the reactant side and we have 4 moles of a gas. So if I increase pressure, equilibrium will shift toward the left hand side. So what I should do? I should decrease the pressure, because decreasing of the pressure shift the equilibrium towards side where number of moles are more. So that will decrease in pressure, shift the equilibrium towards the right. And as the equilibrium shift towards the right, what will happen to yield? The yield will increase, but because pressure and rate are directly proportional, the speed of the reaction will decrease. And if we use a catalyst here, that it won't affect the shifting of equilibrium, it only affect the rate of the reaction. So when you mention that the distribution of the mark, you will mention like if you increase the temperature, equilibrium shift towards right, that will give you 1 mark. And then because the forward reaction is endothermic, that's the second mark. And increasing in temperature increases the rate, that is the third mark. So greater proportion, then explain like when we increase the temperature, greater proportion of molecule have energy more than activation energy. That will give you the fourth mark. And then decrease the pressure, it will shift towards side where number of moles of gas are more, so it is toward the right hand side. But when we decrease the pressure, the concentration also decrease a few collagens, that's why the rate will decrease. Excess of steam is used in reaction 1. Why an excess of reagent is used, and suggest why steam rather than methane is chosen. So why we use excess of steam? So when we use excess of steam, so it means we increase the concentration of the reactant, so equilibrium always shifted towards the right hand side. And why we do not use methane? Because methane, it's not readily available, or the source of the methane is limited. So that's why we prefer to use steam, which is readily available and much cheaper than methane. Copper is a catalyst in reaction. To explain how catalyst increases the rate of reaction. So you have to explain the idea. What catalyst will do? Catalyst will trap the water, like basically they trap the reactant molecules on the surface, and when they trap the reactant molecule on the surface, they reduces the activation energy, lower the activation energy, or provide an alternative route for the reaction to occur. And one economic advantage of reaction 4, potassium hydrogen carbonate give potassium carbonate, carbon dioxide and water. So when we compare the overall reaction, that potassium hydrogen carbonate produce potassium carbonate back again. So what is the advantage here? Like potassium carbonate, which is also a reactant for other reactions, can be used and reduces the cost for the process. Like if the reactant regenerated in any step, then it definitely reduces the cost of a reaction, so that we don't have to react or add more reactant for this reaction to occur. Reaction 4 contribute to global warming, identify a substance that is formed and responsible, and explain the process that lead to increase in, and suggest two effect on increasing temperature, global temperature might have on environment. So basically, even water and both carbon dioxide are greenhouse gases. Why they are both greenhouse gases? Because they have polar bonds. When the molecule is having a polar bond, it has a greater capability to absorb the infrared radiation. So mainly carbon dioxide, but even the greenhouse factor of a methane is much higher as compared to carbon dioxide. So carbon dioxide and water both have a polar bond, so they have tendency to trap the longer radiation and does not allow to escape. So what will be the effect? The average temperature will increase, and that will leads to the melting of the ice at the polar caps and leads to a rise in sea level. In question 19, consider the following ionic half equations. Which of these ionic half equations are all combined and full ionic? So whenever you want to write an ionic full equation, you should make number of electrons same. So we should make number of electrons same. This is 3 and this is 2. So we should multiply this equation by 2, multiply this equation by 3. So it will be 2Al plus 2 aluminum ion, 6 electrons. And then when we multiply this by, so it is 6 protons plus 6 electrons gives 3 hydrogen molecule. When we add the two equation, so 2 aluminum plus 6 protons gives 2 aluminum plus 3 hydrogen molecule will be there. So it matches with 2 aluminum, 6 proton, 2 aluminum ion and 3 hydrogen. So it matches with option D. So whenever you want to write a combined equation, always make the number of electron same. So as you make the number of electrons same and add the two equation, the electron will cancel out and you will get the combined equation for oxidation and reduction half. In question 20, this question is about the Maxwell-Boltzmann energy distribution. The diagram shows temperature, increase in temperature from T1. So if we increase the temperature, what will happen? Number one, the height of this peak will decrease and it will shift toward the right hand side. So D is totally wrong because it is not shifted, it is on the same side. Then we check the height of, at we increase the temperature, the height of the peak should decrease. So this peak height is not decreasing. So either we will, and here also the peak height is not decreasing. So what basically happens when we increase the temperature, the height of this peak will decrease and it will shift more towards the right hand side. These are the two things happen due to increase in temperature. That's why B is the right answer, because as in most greater number of a molecule now will have higher energy. That's why the peak is shifting towards the right hand side. Next is question 27. Consider the following simplified equilibrium for indicator. So addition of few drops of sodium carbonate. So sodium carbonate, what will be the effect? So you have to first identify which reagent it reacts. So sodium hydrogen carbonate, it will produce sodium ion and carbonate ion. And carbonate can react with acid. So as the carbonate can react with acid, acid means H plus. So if carbonate can react with acid, so in the mixture, the amount of hydrogen ion decreases. So as the amount of hydrogen ion decrease, where the equilibrium will shift, it will shift towards the right hand side. As the equilibrium shifted towards the right hand side, what we'll get? We'll get more purple color. That's why D should be the right answer. Is it clear? Question 27. So it is important that you identify which reagent in the mixture will react with the chemical added. In question 28, in a reaction, change in concentration of a product with time is shown. The dashed line X on the graph below. So Basically, the question was which factor, like what should be the graph. The question is it's incomplete. Where the question was what will be the graph if we increases the surface area or using a catalyst. So that's why B will be the answer in that case. But the question part is missing. That's why you cannot complete this. Next question 29. The Maxwell-Boltzmann distribution graph used to illustrate the effect of temperature. Which area of a graph shows or indicate the increase in number of the molecule that will react or that will have sufficient energy. So in the beginning it was D. As you can see in the beginning, when there was low temperature, the temperature was around 400 Kelvin. So this is D. And then this, when we increase the temperature, this is the extra part. This is a now extra molecules which will react and form a product. This region C is D is already there. They were reacting. Now when we increase the temperature, the molecule which are under this region, they will also react. So it means area C is the part of the molecule which shows that they will also react and form a product. The total number of the molecule is actually C plus D, but the area which is increased here, because in the question they mentioned which area of the graph indicates increase in number. Like they're not talking about the total number of the molecule which are reacting. If they ask total number of the molecule which are reacting, then C plus D should be the answer. But how many molecule have D were already reacting. But when we increase the temperature, this area molecule will also react. So the increase is actually by C. Then 31 is there. A concentrated solution of a bromine water is orange. Which of the following equilibrium exists in the solution? So what would be the effect if any of the, if we add sodium hydroxide? So if we add sodium hydroxide, so we have to again check which reagent it reacted with. Sodium hydroxide is a base, so it will react with acid. Amount of hydrogen ion in decrease, so where the equilibrium will shift, it will shift towards the right hand side. But it's not like still, because it's a reversible reaction, so still you will have reactant. So whenever you have reactant, it's still present. So you cannot say it become colorless. If you say it become colorless, that's wrong, because still there are molecules of bromine, but few molecules are there, so the color of the solution will become lighter. That's why B is the right answer. Next is 34, part A. Show by calculation the solution contain 2.2 gram per dm cube of a bromine is richer in bromine than one contained 60 parts per million. So we have to find the moles of a bromine or number of the moles of bromine concentration. It can be mole per dm cube or it can be parts per million as well. So if we have a concentration of 2.2 gram per dm cube, so it means 2.2 gram per dm cube or 1000 cm cube. And when we work out, because in the question they're asking, show by calculation a solution that contained 2.2 gram per dm cube of a bromine is richer in bromine than one containing 60 parts per million. And assume that 1 dm cube of a bromine solution is about 1000 gram. So when we work out amount of a bromine, because this is 2.2 per dm cube, or as they mentioned, 1 dm cube is 1000 gram. So it means it is 2.2 gram divided by 1000 gram. So 2.2 divided by 1000. And when we work out this in this concentration in per million, so we have 2.2 gram per 1000 gram. If we need parts per million, like we want to convert this into 1 million, so in 1 million gram, how much bromine will be there, or what is the mass of bromine X? Cross multiply. So when we cross multiply, it will be 2200 gram per million. Or if we have 1 million molecules, then out of 1 million molecules, or out of 1 million gram, we'll get 220 grams of bromine. So this shows the concentration to be 2200 ppm, parts per million. And when we work out, like when we compare the two values, as I mentioned, this is 60 parts per million, but if we have 2.2 gram per dm cube, it means it contains 220 parts per million. Like 1 million, it contains this much of bromine, because the formula concentration in ppm is equals to mass of solute divided by mass of solvent into 1 million. So when we have this factor, like we have this 2.2 divided by 1000 is there, and then we multiply by 1 million, so we'll get the concentration in ppm, which is 2200 ppm. So the concentration of 2.2 gram per dm cube means it is 2200 parts per million, and which is obviously more than 60 parts per million. Then the last question is 35. The energy marked X is a Maxwell-Boltzmann distribution. So what this X is representing, this is not the actual average energy. It means greater number of the particle will have this energy. So when we check the options, the most common energy of a molecule, activation energy, the number of the molecule with energy greater. So this is not the this is the most common energy the molecule have. So A should be the right answer for this. So for 35, A will be the right answer. So these are the doubts related to topic rate, redox, and reversible. Any other question or a doubt?